students, here is the question number 38. In a reaction between A and B, the initial rate of reaction R0 was measured for different initial concentrations of A and B. These are given below. Have a look on that. A, you have its concentration in mole per liter is given, that is 0.1 initially. Similarly for the B also, the concentration is 0.1 mole per liter, and at that time the rate of the reaction is 2 into 10 raised to the power minus 5. Similarly, when the concentration of A is changed to 0.3 and the concentration of B remains unchanged, constant, then the rate of reaction becomes 6 into 10 raised to the power minus 5. Similarly, when the concentration of A becomes 0.4 mole per liter and the concentration of B becomes 0.5 mole per liter, then the rate of the reaction becomes 4 into 10 raised to the power minus 4. What you need to do? What is the overall order of the reaction? That you find. How? On the basis of the comparison of the rate of reaction with the given concentrations. Let's first of all have a look on the concentration of A. It is 0.1 here, and you have just changed it to 0.3, then the rate of the reaction becomes 3 times. This was 2 into 10 raised to the power minus 5 and this is 6 into 10 raised to the power minus 5. While if I talk about this value, concentration of B, that is same in both of these cases. Is it? Yes. So, if this is constant, only the change in concentration of A is affecting the rate of reaction, and as the concentration of A is triple, the rate of the reaction is also triple. It means it is directly proportional to the concentration, rate of the reaction at this time. And very simple to say, with respect to A, the order of reaction is 1. Now, the next is the turn to compare the rate with respect to B. Have a look. When the concentration of A becomes 4 times, from 0.1 to it is getting changed into 0.4. The same case, it is getting changed into 0.1 to 0.5. And what happens to the rate of the reaction? See, initially it was 2 into 10 raised to the power minus 5 and now it becomes 4 into 10 raised to the power minus 4. What is the relation? Very simple, the rate becomes 20 times in this case. So, very simple to write. When the concentration of A is changed 4 times, while concentration of B becomes 5 times. Then in this particular condition, the rate of the reaction becomes 20 times. And the effect of the change in concentration of A, you already know. With respect to A, this is first order reaction. It means if the concentration of A is double, rate of reaction gets double. If concentration of A is triple, rate of reaction gets triple. So, in the similar basis, if I talk about this case, it becomes 20 times, and with respect to A, it becomes 4 times. So, definitely with respect to B, as you were changing the concentration of B here from 0.1 to 0.5, it means you are increasing, you are raising it 5 times. Then the rate of the reaction with respect to B is also getting changed into 5 times. 4 times with respect to A and 5 times with respect to B when you were changing the concentration of A 4 times and the concentration of B 5 times. So, very simple to relate here that the order of the reaction with respect to B is 1 also, because directly proportional, that is with respect to this is 1, with respect to A is also 1. So, overall order of the reaction is, yes, 2. Order of the reaction is 2, and on the basis of this you can easily choose the correct option. Check the option that is correct over here. In this case the correct option is given here. This is option 1. Just choose it as the correct answer. I hope it is clear. Now the turn is for the next question. Question number 39. Among the following, which is an example of positively charged sol? The question from surface chemistry, and if you have a look on the given options, you will see that copper, arsenic trisulfide as well as gelatin, all 3 are the negatively charged sols. Only this methylene blue, this is a positively charged sol. And if it is so, yes, the correct answer that I am just going to choose here is methylene blue. I hope this question is also clear to you, and yes, the turn is there for the question number 40. Which of the following is an ore of iron? See, different ores are given. If I talk about cuprite, what is its composition? This cuprite is Cu2O. It means it's an ore of copper, not of iron. Further, magnetite. Magnetite is Fe3O4. This is the composition. Yes, this is an ore of iron. Further, copper glass, if I talk about, name also suggests so. Copper glass is Cu2S, cupric sulfide. Further, calamine, zinc carbonate, it is ZnCO3. Now, very easy to identify. Only one ore of iron is given in these options, that is magnetite. And yes, on the basis of this, the correct answer becomes option 2. Now, the turn is for the next question, that is question number 41.